Hello, my name is Matthias and I'm data scientist at Clario. Today I want to explain why we need streaming or so-called online algorithms by means of a use case. The use case we will pick is to develop a fraud detection classifier and a specific well-known algorithm, random forest. So let's say we have a labeled data of credit card transactions and we build a random forest classifier. This random forest is an ensemble learning method in which a majority vote gives the final classification. This majority vote is based on the different trees that are forming the so-called forest. Now, the business expands and you have much more customers and transactions and a higher chance of fraudulent transactions. So with this business expansion, there are two problems that are inherent to the business expansion. The first one is that we have a lot of new data, which is almost impossible to store all historic transactions. And the second is that because fraudulent transactions need to be seen very quickly, we have the problem that the algorithm should be trained very fast. For a random forest classifier, we need to go over the total data set multiple times. First, we need to go over the entire data set to generate the different bootstrap samples that we will need to build a tree for every sample. The second time we need to go to the total data set or parts of the sample data set is for each tree to decide at which attribute and split point we actually want to split. So obviously we are in a context of new data on subsequent timeframes that comes in our database, and we would need to go over the total expanded data set every time that a new data point comes in. So you can imagine that this algorithm will scale poorly with the size of your data set. And since we have an expanded business, this data set will increase rapidly. But of course there are frameworks such as Apache Spark, the MLlib, that can distribute this workload. But as those data sets will expand fast, implementing this algorithm is not sustainable and not a cost-efficient solution. So preferably we only see the data once, and that should be enough to develop a random forest. And then we are more in the terrain of the online random forest. So dealing with the second problem in fraudulent detections is that the classification needs to be fast and sufficiently agile if there is a concept drift. So we want to have the new models classifying fast, and as discussed, it should be able to deal with concept drift. In order to have this model, we definitely have to switch to the online version of random forest. In this version, the new streaming data will contribute to the formation of a growing tree in such a way that every labeled record that is incoming is routed through the appropriate nodes of the tree that is under construction. So as a sideline, please note that therefore we need more labeled data than for the static method, because in the static method we use bootstrap aggregating. But now here for the online, the incremental random forest, every new labeled data that comes in will only be used once. So going back, whenever a node accumulates a minimum number of labeled records at the node that is currently developing, the Gini index and the Hovding bound tests are applied. So if the Hovding bound test is satisfied, then the frontier node has seen enough records to determine the best attribute and the split value. And how is that determined? That's based on the Gini index. And the Gini index is used to select the best attribute and split point. And in such a way the frontier node is transformed into an internal node, and this internal node will then split back to two new frontier nodes that are being developed, and in which new data that is coming in will flow to these new frontier nodes. In such a way, every time a tree is built, it gets added to the random forest. So in order to deal with the concept drift, there are multiple ways to deal with that. So you have your forest with a lot of growing trees and trees that are added to the forest. And so what you can do, for instance, is say the last or the oldest trees, I will get rid of them, so that your forest, that the number of trees in your forest is continuously or is constant, is kept constant. Or you can say the trees that are less performant for, let's say, 4 or 5 times, they will get thrown away out of the forest. So in such a way, we developed the online, or we explained how to develop the online streaming random forest that can deal with an expansion of data, with ever-growing data, and it also can deal with a concept drift. So we solved the problem of looping through all the data, and we can update the classification algorithm fast and with enough resources. So the main drawback of this talk is if you have loads of real-time data and you want to have as fast as possible decisions on your data, you need at least a fast algorithm that is scalable and cost efficient. And then you should try to implement online algorithms. There are a plethora of online algorithms out there, and today we briefly discussed one of them and pinpointed why they are useful and how they are applicable to the industry. Thank you for watching this video, and I hope to see you on the next one.